Where to write an algorithm in AI, ML, or deep learning. Pradeep K. Suri. Author and researcher. Deciding whether to write an algorithm in AI, ML, or deep learning depends on the problem at hand, the available data, the desired level of automation, and the specific requirements of the application. Here's a step-by-step process to help you make a decision. 1. Define the problem, clearly articulate the problem you are trying to solve. Identify the task or objective you want to achieve with your algorithm. This could be anything from image recognition to natural language processing or recommendation systems. 2. Assess the data, evaluate the type, volume, and quality of the available data. Determine whether the data is structured or unstructured, labeled or unlabeled, and whether it is suitable for training ML or deep learning models. Deep learning often requires large amounts of labeled data to generalize well, while ML algorithms can work with smaller data sets. 3. Consider complexity, assess the complexity of the problem and the relationships between variables in your data. Deep learning is particularly effective when dealing with complex patterns and nonlinear relationships. If your problem requires capturing intricate patterns, such as image or speech recognition, deep learning may be a good choice. For less complex problems, ML algorithms can often provide satisfactory solutions. 4. Available resources, evaluate the computational resources available to you. Deep learning models are typically computationally intensive and may require specialized hardware such as GPUs or TPUs for efficient training. ML algorithms are generally less resource demanding and can be trained on standard hardware. Consider whether you have access to the necessary computational infrastructure to support your chosen approach. 5. Expertise and time constraints, assess the expertise and experience available within your team. Deep learning models often require specialized knowledge in designing and training neural networks. If you have experts in deep learning, they can guide the development process effectively. ML algorithms, on the other hand, have a wider range of readily available libraries and tools, making them more accessible to a broader set of practitioners. Consider the expertise within your team and the available time to invest in learning and implementing different approaches. 6. Evaluate trade-offs, consider the trade-offs between accuracy, interpretability, and performance. Deep learning models can achieve state-of-the-art performance but may lack interpretability and can be prone to overfitting. ML algorithms tend to be more interpretable but may have lower accuracy on complex tasks. Assess the importance of interpretability and the specific requirements of your application. 7. Experiment and iterate, it is often valuable to experiment and iterate with different approaches. Start with simpler ML algorithms and assess their performance. If they don't meet your requirements, gradually explore more complex ML algorithms or deep learning models. Experimentation will help you find the best approach for your specific problem. Remember that the decision between AI, ML, and deep learning is not always binary. They are interconnected and can be combined. AI encompasses a broader scope that includes ML and deep learning as subsets. Depending on the problem, you may need to incorporate multiple techniques or utilize a hybrid approach. Ultimately, the decision should be driven by the problem's characteristics, data availability, resource constraints, and the expertise and time available to you and your team. Thank you.